So the pictures on the front side have just changed, but everything else will match. So today for our first lesson, we're going to look at operations that involve imaginary numbers and add them, subtract them, multiply them, and divide them. Well, first thing we've got to figure out is what is an imaginary number? Oops. So first thing, we have been finding solutions. Remember, we've been finding where our graph crosses the x-axis. So this whole time, I better not do that. Let's say our graph crosses here. We've been finding these points right here. When we factor them, we just call them our solutions. When we graph them, we call them our x-intercepts. There are actually two other names for them. We could also call them the zeros. So we could also call them the zeros. Remember, when we factored them, we set our factors equal to 0. That's where the word zeros comes from. And then the last one, which we don't use very often, the word roots. So these four terms here, solutions, x-intercept, zeros, and roots, all mean the same thing. We're finding out where your graph's crossing the x-axis. There's just multiple modalities of finding it. We can graph it, we can factor it, we can use the quadratic formula, and all get to the same place. But today we're going to look at graphs that don't actually cross our x-axis, and we're going to find their solutions. Their solutions come in the form of imaginary numbers. So we're going to do a little bit of practicing before we try those out. So some vocabulary. The imaginary number is just a lowercase I. And I is just equivalent to the square root of -1. So if you have a calculator and you type the square root of -1 into it, so square root, then -1, it's going to give you some type of error message. So you can't compute the square root of -1 in your calculator because it's an imaginary number. We can get around that if we would take the square root of -1 and we square it. The square and the square root would cancel. We'd have to square the other side, and that's how we arrive at this down here. So if we take the square root and we square it, square the I, so then we end up with I squared equals -1. So anytime we have a problem and we have I squared in it, we can replace it with -1. Or if we have the square root of a negative number, we can take out an I. So I'm going to skip down to the bottom. So there's the technical definition underneath your property. But down here, if I look at the square root of -81, what that really means is I have the square root of -1 times the square root of 81. Because -1 times 81 is -81. From the top up here, I know that the square root of -1 is just I. I also know that the square root of 81 is 9, and we normally write that 9 out front. So that's how we arrived at this 9i right here. So anytime you have that negative underneath, you just put an I with your answer, essentially. So the second one, the square root of -121. The negative comes out as an I, and the square root of 121 is just 11. So 11i would be our simplified answer. And then the last one, the square root of -5, the negative comes out as an I. We don't know the square root of 5, that's why we left it as the square root of 5. So for that last one, you just take out the negative, turn it into I, and then you leave your square root of 5 alone. Because you don't know what the square root of 5 is and you can't simplify it anymore. Let's practice. All right, so for letter A, we have the square root of -2. I know I've got a negative, so I know my answer has to have I in it. Can I simplify the square root of 2? No, I'm going to leave it as the square root of 2. So this simplifies as I times the square root of 2. So all we did is take that negative, move it out in front to an imaginary number. For letter B, I know automatically I'm going to have an I in my answer, but then I'm going to look at 12. 12 does simplify. I can break 12 up into the square root of 4 times the square root of 3. Well, the square root of 4 is a perfect square. Square root of 4 is 2, so I'm going to have 2i, and then my square root of 3 stays the same. I don't know what the square root of 3 is. So that right there would be my answer. And then for the last one, I know the negative is going to come out and become an I. 36 is a perfect square, so it's going to come out as a 6. Again, we always write the number first and then the I, so 6i would be my final answer. So the square root of 36 is 6. The negative comes out as an I. That's going to lead us to the next thing we're going to do. We are going to look at complex numbers. It's just a fancy way of saying we have a real part and we have an imaginary part. So complex numbers can be written in the form a plus bi. Sometimes you'll see this written on like a test. It's write your answer in the form a plus bi. That just means write the real number first and then the part that has an I with it second. So any number you can think of until today has been a real number. So any fraction, any decimal, any square root has been real. Until we start putting those I's in there, then that's your imaginary part. So when we add and subtract complex numbers, all we're going to do is combine the real parts with the real parts and the imaginary parts with the imaginary parts. So when I look at this first example down here at the bottom, we have 5 plus 7i plus, we're adding these two parentheses together, -2 plus 6i. So my real parts, since I'm adding, all I have to do is combine my like terms. So I have a 5 that's positive and a -2. So 5 minus 2 gives me 3. We're just putting those two together here. Then we're going to put the imaginary parts together. We've got a 7 and a 6i. They're both positive, so I'm going to take 7 plus 6 to get 13, and then I'm just bringing the I down with it. So treat it just like you would 7x plus 6x. 7x plus 6x would be 13x. Instead of an x, we have an I. So that would be your final answer, 3 plus 13i. The second example is a little bit trickier because it has a minus sign here. So that minus sign is like a -1 sitting out in front of this second set of parentheses. The best way to get rid of it is just to distribute it into that second set of parentheses. So leave the first set alone. And then if I take -1 times -2, I get +2. If I take -1 times +6, I get -6. Bring your I down with it. Now we have a problem just like the one on the left. Combine your real parts with your real parts, your imaginary with your imaginary to get your final answer. So 5 plus 2 gives me 7. And then 7i minus 6i gives me 1i, or you could just write I. So 7 plus I or 7 plus 1i, either answer works there. So at the bottom of your paper, you have 3 problems. I want you to work on those. They're just like these. Combine your like terms. Make sure if you have that negative that you distribute it. So for letter A and letter B, you're going to distribute that negative. So for the first one, I distributed that -1, which gave me -2 minus 4i. So when I combine, I'm going to combine the 8 minus 2 to get 6, and 3i minus 4i to get minus 1i, or just minus I. And like normal, you don't have to have that 1 in front of your I. For letter B, again, you have that -1 sitting out front of your parentheses. You want to go ahead and distribute. So 7 minus 3 minus 2i. When I go to combine like terms here, all I've got for like terms is the 7 minus 3, which is 4. And then you're just going to bring down the minus 2i. There's nothing to combine it with, so you just bring it straight down. And the last one, letter C. Here we have parentheses. There's no negative out in front, so there's no distributing that needs to be done. All I need to do is combine like terms. Well, when I look at the real number, there's no other real numbers in the problem, so I'm going to bring it down. Then I'm going to combine my -6i with my 3i, so -6i plus 3i is -3i. Final answer. Questions on these 3? Hopefully pretty easy. On the next page, we're going to start multiplying complex numbers. When we multiply them, you can either use the rectangle method or distribute. Either way works. I tend to use the rectangle method because students tend to lean that way here. So if you're doing it the distribution method, your numbers will be the same as what we have in our boxes. And then I wrote us a note to remember that I squared equals -1. Hint, at some point we'll end up with an I squared in our problem. So we're going to multiply 2 plus 3i times -3 plus 5i. So if we're using the rectangle method, we write one of our factors across the top or bottom, and then one across the side. And then we're multiplying corresponding numbers. So if I'm starting in this box right here, I'm looking up and I'm looking to the left to figure out what 2 numbers I'm multiplying together. So in this case, I'm going to take 2 times -3. So for the top left box on mine, 2 times -3 is -6. If I move to the top right box, I'm taking 3i times -3. Well, 3i times -3 just means -3 times 3 is -9, and the I gets brought down with it. Bottom left box, I'm taking 5i times 2. Well, 5 times 2 is 10. The I comes down because there's only 1. And then my tricky box, I'm taking 3i times 5i. Well, 3 times 5 is 15. And then I times I is I squared. Well, remember, this I squared gets replaced with -1. So what this really means is I'm taking 15 times -1, which gives me a value of -15 for this bottom box. So I've taken the I squared out, replaced it with -1. -1 times 15 gave me that -15. So now when I go to write my answer, all I need to do is add my real parts together, add my imaginary parts together. So when I go to add these together, I have -6 plus -15, which is -21. I have a -9i and a positive 10i. -9 plus 10 is +1. The I gets brought down. So final answer for this multiplication problem is -21 plus I. All right, on the next slide, we're going to do some more practice problems. The first one, you have one term times one term. So you're going to take 12i times 7i. 12 times 7 is 84. And then when I take I times I times I is I squared. You're never allowed to leave I squared in your answer. You must simplify it. We know that I squared equals -1. So this is really 84 times -1, which is -84. For letter B, we have two sets of parentheses that we need to multiply together. So I'm going to put the first one on the top of my box, the second one down the side. Make sure that since I have a -5i or a -5i, that has to go with the -5i in my box. And then the -3i or the -3i has to go with the 3 when I write it along the side of my box. So now I'm going to take and I'm going to multiply corresponding parts. So top left box, I'm taking 6 times 4, which is 24. -5i times 4, which is -20i. -3i times 6 is -18i. And then be careful, this bottom box, I'm taking -5i times -3i. Well, -5 times -3 is 15. I times I is I squared. I'm not allowed to leave I squared in my problem. I'm going to replace it with -1. 15 times -1 is -15. So that box, or that part of my box, has a value of -15. To get my final answer, I'm just going back to my box and combining like terms. I have 24 and -15. When I add those together, I get 9. Then I have -20i and -18i, which is -38i. Again, you're just adding them together like you would x values. So take a minute and see if you can do letter C. Again, I don't care if you use the box method or if you distribute. Either way. So hopefully you got a final answer of 43 minus 24i. If you have questions or you didn't get that answer, let me know. All right. So dividing complex numbers, there are 6 steps if you want the long, drawn out directions. Really, it's just 2 multiplication problems in one. So the first thing you have to do is figure out what the conjugate is. So we need to multiply the top and the bottom of this fraction by the conjugate. The conjugate just means go to the bottom, the denominator, and you're going to change just the sign in the middle. So for my conjugate, I would have 4 plus 3i. So all you're doing is going to the denominator, looking at the sign in the middle, only that sign in the middle, and you're going to change it. And then we're going to multiply both the top and the bottom by that conjugate. So we're going to multiply the top by 4 plus 3i, and we're going to multiply the bottom by 4 plus 3i. That's why we have 2 boxes drawn for us on this slide. So I'm going to do the numerator in the first box. So my numerator, I had 3 plus 2i, and then I multiplied it by the conjugate 4 plus 3i. Then I'm going to do exactly what we've been doing. We're going to multiply corresponding boxes, or corresponding parts to the box. So the first top left box, 3 times 4 is 12. Top right box, 4i times 4 is 8i. 3 times 3i is 9i. And 3i times 2i is 6i squared. Again, we've got to get rid of this I squared, replace it with -1. So -1 times 6 is -6. So all of this simplifies. If I add my like terms together, 12 minus 6 is 6. 8i plus 9i is 17i. That's going to be the numerator of my answer. So down here, I've just started my answer, and I put what I just got in the numerator, and then I'm going to have to figure out what goes in the denominator. So for the denominator, we're going to take the original, 4 minus 3i, and we're going to multiply it by the conjugate, 4 plus 3i. Then we're going to go through and we're going to multiply. 4 times 4 is 16. -3i times 4 is -12i. 4 times positive 3i is positive 12i. And for my last box, -3i times positive 3i is -9i squared. Again, we're never allowed to leave this I squared. We got to replace it with -1. -1 times -9 is positive 9. So that box actually has a value of positive 9. When I go to combine like terms, I'm going to combine 16 plus 9, which gives me 25. What's going to happen when I add -12i and 12i? They're canceling out. If you do this correctly, these 2 boxes should always cancel each other out. When we divide complex numbers, we're really just eliminating all the imaginary numbers from the denominator. So you should never have an imaginary number left in your denominator in your answer. So the I should cancel, the I squared should get replaced with -1, and you should just have a regular number in the denominator. So in this case, 25.
Can you explain to me how
So that's called the conjugate. So we're going to take whatever's in the denominator and change the sign in the middle. So we always change that sign right there. And that's what we multiply both the top and the bottom by. So So you do only for the denominator. So you just look at the denominator because that's what we're trying to eliminate the i's from. And by changing this sign, that allows for this cancellation to happen here. So that's why we do it, because it gives us this 12i and the negative 12i, which we can cancel the i's out of.
Okay.
Good question. Let's practice a couple more. So first thing we're going to do, we have to figure out what to multiply by. How do we figure that out? We go to the bottom. The only thing you're allowed to change is the sign in the middle. So the only thing we're changing is that plus 2i to a minus 2i. So our conjugate is 1 minus 2i. We've taken the denominator and we've just changed the sign in front of the imaginary number. And if we do that correctly, when we multiply for the denominator, our i's should cancel. I squared gets replaced and there's no more i's in the denominator. So again, I'm going to do the numerator in the first box. So 1 minus 3i times 1 minus 2i. Then I'm going to fill it in. 1 times 1 is 1. 1 times negative 3i is negative 3i. 1 times negative 2i is negative 2i. And negative 3i times negative 2i is 6i squared. Can't leave that I squared in there, so we're going to replace it with negative 1, which gives us a value of negative 6 for that bottom box. So when I combine like terms, I already know that is going to be the numerator of my answer. So I know that I'm going to have negative 5 because 1 minus 6 is negative 5. And negative 3i minus 2i is negative 5i. So I know that's going to be the numerator of my answer for this first question. Then I'm going to fill out my denominator. So I'm going to have the 1 plus 2i and the 1 minus 2i. And if I've done it correctly, all of my i's should cancel out. So 1 times 1 gives me 1. 2i times 1 is 2i. Negative 2i times 1 is negative 2i. And negative 2i times positive 2i is negative 4i squared. Take the I squared out, replace it with negative 1. So negative 4 times negative 1 gives me a value of positive 4. So when I go to combine like terms, I have 4 plus 1, which is 5. And then my 2i and my negative 2i cancel out right there. Technically, this answer should be reduced. You can divide all three terms by 1. So negative 1 minus I, you don't have to even say that it's divided by 1. So you could have that answer too. So if you reduce it, it's negative 1 minus 1i. You want to try the next one on your own, or you just want me to do it? So first thing we're going to do, figure out what the conjugate is. The conjugate, again, only looking at the denominator, change the sign in front of the imaginary part. So negative 6i. So 2 minus 6i is our conjugate. That is what we're going to multiply the top, the numerator, and the denominator by. So for our numerator, we're going to take the 4 plus 5i and we're going to multiply by the 2 minus 6i. So for this numerator, I'm getting 38 minus 14i. Then I'm going to work through my denominator, 2 plus 6i and 2 minus 6i. So for my denominator, my 12i, my negative 12i cancel, leaving me with 40. And the denominator, and actually all these numbers are even, so I can go ahead and reduce them all. I can divide them all by 2, which gives me 19 minus 7i all over 20 as my simplified answer. Questions on how to divide complex numbers? So really all you have to remember for dividing complex numbers is to multiply the top and the bottom by the conjugate. So really it's just 2 multiplication problems, but you've got to know what to multiply by. So on the next page, you will see some circled problems. They're almost all the evens until you get to the back, and then you have to do question 15. If you have questions, please let me know.